We're going to look at number 10 first. The directions for number 10 say solve and check. Solve and check. So this whole little section you'll be solving equations. I'm going to go ahead and start with number 10 because it gets a little bit harder once you get to, once you solve a few. You do not have to do a written check. If your directions say solve and check, a check can be a mental check, and that just means when you get your final answer that you plug your x value that you solved out to get, and you just plug that back into your original equation. Okay? This is obviously a little bit harder equation. The very first problem is 7x minus 5 equals 72. Okay? The very first homework problem is 7x minus 5 equals 72. I didn't want to waste my time working one of those because I know that you can solve that one. I want to go ahead and start with something that's a little bit harder. So when you're solving a big equation like number 10, I want you to think of this equation as a left-hand side and a right-hand side. So on the left-hand side, can we do anything to simplify the left-hand side of our equation? We can distribute. So let's distribute. That gives us 2x minus 2 plus 3. And then on the right-hand side, we get x what? Minus 3x minus 3. Okay? Take a look at your left-hand side again. Is there anything that you can simplify on the left-hand side? On the left-hand side, you have any like terms? Anything we can simplify? The negative 2 and the positive 3. What do they combine to be? Positive 1. Okay, the left-hand side is now completely simplified. Go to the right-hand side. Is there anything that you can combine or simplify on the right-hand side? The x's. So what's an x and a negative 3x combined to be? A negative 2x, and then you just bring down the minus 3. Any questions about how I just simplify the left-hand side? And then just simplify the right-hand side. Don't get all caught up in the equation yet. Just simplify each side. Get down to this step here. Now my problem is if I'm solving for x, I have an x on the left-hand side and I have an x on the right-hand side. That's no good. If you're solving for a variable, you want all those variables to be on one side. So which x is the smallest? The negative 2x. So I've always been taught to move the smaller x. So negative 2x is the smaller x, and I can move it by adding it. Or you can say you can take the negative 2x and move it to the left-hand side, and the sign changes to a positive if you've been taught that. 2x and 2x combine to be 4x, bring down your plus 1, equals what? Negative 3. And then finally we get to what we consider a two-step equation. 4x plus 1 equals negative 3 is a two-step equation. And you'll have some easier problems just like 4x plus 1 equals negative 3 in the beginning of your homework assignment. But we're still solving for x. Okay? We're still solving for x, so that means we've got to get rid of 4 times x. And we've also got to get rid of adding 1. And you have to do one of those first. Which one is it? The 1. You always get rid of adding and subtracting numbers on the side of your variable. You always need to try to do that first if at all possible. So we're going to subtract 1 from both sides. We're finally going to get 4x is equal to what? Negative 4. 4x is equal to negative 4. Still trying to solve for x. X is being multiplied by 4, so we're going to divide by 4. And our final answer is negative 1. And again, I picked one out right away. That was one of the hardest problems in that first set of your directions of your homework. They're not all that difficult. Okay? Simplify the left. Simplify the right. If you have a variable on both sides, get those variables on the same side, and then you'll have a two-step equation from there. Questions about number 10? Okay? Your equations can get a little bit more difficult if you have things in the denominator. So I picked number 22 to show you that this equation is a little bit more difficult. Doesn't look as hard as number 10. It doesn't look as hard as number 10. It's not as long as number 10. It doesn't have any distributing in it. But number 22, the thing that we don't like about number 22 is we don't ever like for there to be anything in the denominator. So we can do something that we did back in chapter P, and we can clear the fractions. That means we want to get rid of the denominators. So what is a number that I can multiply by that 2 will cancel into, that 4 will also cancel into? 2. Will 4 go into 2? I have to have a number that 2 will go into and 4 will also go into. 8. Something not as big as 8, but bigger than 2. 4. You can use 8, okay? There's nothing wrong with using 8, but sometimes we like to use a smaller number. 8 would also work, okay? 4 is considered our least common denominator. That's another way to find that number of your two different denominators or your different denominators that you have. So what we're going to do is we're going to multiply everything in the equation by 4. That's legal. As long as you multiply everything on the left-hand side by 4 and everything on the right-hand side by 4, that's legal. So 4 times x over 2. 2 cancels with 4 2 times. 2 times x is 2x. Multiply times the next term. 4 times 3x over 4. The 4's completely cancel and you just have 3x. 4 times 5. Nothing cancels, guys. Nothing cancels with 4 times 5 because 1 is in the bottom of 5. So you actually have to do 4 times 5, which gets you 20. Okay, so that little step by multiplying through by something that your two denominators will cancel into clears your fractions. It gets rid of your fractions. Is the left-hand side of your equation simplified?
Yes.
Yes. Is the right-hand side of your equation simplified? Yes, you can't add 20 to 3x. Do you have variables on both sides? Yes. Which one is the smallest? 2x. So we usually move the smaller x wherever the larger one is, but why would we not want to do that in this particular situation? If we move the 2x over, nothing is left on the left-hand side. And we don't usually like to do that when we're solving. So in this problem, because if I move the 2x, nothing will be left on the left-hand side, I'm going to move the 3x. And since 3x is positive, I'm going to move it by subtracting. So I get 2x minus 3x, which is negative. X is equal to, 3x is canceled, 20. Alright, bless you, bless you. So, have we solved for positive x? Because we are solving for positive x. We hadn't solved for positive x because my little x is being multiplied by a negative 1. So my last step is to divide both sides by negative 1, and x solves out to be negative 20. Again, it's asking you to solve and check. Solve and check. So you can just take your negative 20. You can go back into your original problem. Wherever you see the x's, you'll plug in the negative 20, and you'll actually check to make sure that it is a solution to the equation. I'm going to check this one just to make sure you know how. So you go into the first x. It's up here. So if that x becomes negative 20, what's negative 20 divided by positive 2? Negative 10. So here's my check. And again, I think most of you can probably do part of this mentally. Go into the next x. This is the next x. It's been multiplied by 3. 3 times negative 20 is negative 60. Negative 60 divided by positive 4 is a negative 15. And then I have that plus 5. So if x is negative 20 and I plug it back into my original equation, is negative 10 going to be equal to negative 15 plus 5? Yeah, because negative 15 plus 5 is negative 10. So you can tell right here that your answer checks. Okay, do you have to check all of them? If you check them mentally, I don't know that you're checking them. But especially when you take your next quiz, if you're solving, you can always plug your answer back in to see if you have the correct answer. Any questions about checking? All right, let's look at number 30. Number 30 is similar to 22. It has some denominators. It's a little bit longer. So again, when I'm looking at this equation, what I see that I want to get rid of automatically is the 5, the 2, and the 3. And this is something else that's going to come into play is, are there any excluded values? This is something that we studied back in section P6. Are there any excluded values? Even on the test, I had you write, how do you find an excluded values? Where do excluded values come from? One specific location. They come from the denominator, okay? Do you have any variables in the denominators of this equation? You have no variables in the denominator. So that 5 could never turn into a 0, right? The 2 and the 3 could never turn into a 0. So you don't have any excluded values in this equation. You won't have any excluded values until you have variables in the denominator. Variables in the numerator, okay. It's okay to have 0 in the top. You just can't have 0 in the bottom. So let's clear the fractions. I've given you some time to think about this. What can I multiply by that 5 will go into, that 2 will go into, and that 3 will go into? 30, okay? Is there a number bigger than 30 that you could use that those 3 numbers will divide into? Probably, okay? So you can use a bigger number if you want to, but I always like to do the least common denominator. As long as all 3 of those will go into it, you can still get the right answer. All right, when we multiply 30 times the first term, 5 goes into 30 how many times? 6. Now I'm going to put this step in because I think it's important. So you're going to have to do 6 times 3x. Some of you may be able to skip that step and just write 18x. If you can, that's great. But when we get to the next binomials, this is a little bit harder. When we multiply times the second term, 2 goes into 30 how many times? 15. Now, I don't want you to skip this step. I want you to bring down the minus. I want you to do 15, and then I want you to do parentheses. We're having to do parentheses because I have more than one term in that numerator. All right, so it's going to be negative 15 minus negative 15 parentheses x minus 3 times the last term. 3 goes into 30 how many times? 10. And then I need you to do parentheses. Anytime you have more than one term, put those terms in parentheses because that means I'm going to have to distribute. And if you forget your parentheses, you're probably not going to distribute completely like you should. Any questions about this step? This is usually the hardest step to get, and the rest of it is a little bit easier. Any questions about where the 6, the negative 15, and the 10 came from? All right, so now we're going to simplify the left-hand side, and we're going to simplify the right-hand side, and then we're going to solve. So on the left-hand side, I get 18x minus 15x plus 45. On the right-hand side, I get 10x plus 20. Is the left-hand side simplified? No, it's not, because I can combine 18x and minus 15x to give me 3x. So now the left-hand side is 3x plus 45. And the right-hand side is 10x plus 20. So now both sides of the equations are simplified. That's what you want to do first. Now you want to start to solve. So do you have variables on both sides? Yes, you have a 3x on the left and a 10x on the right. Which variable is the smallest? 3x. So let's move the 3x. It's a positive 3x, so we're going to move it by subtracting. That's going to leave me with 45 is equal to 7x plus 20. 45 is equal to 7x plus 20. X is on which side at this point? It's on the right-hand side. So if you're solving, you're looking at the right-hand side because that's where your x is. You could care less about the 45. So you're looking at 7x plus 20, and we're solving for x. So what would we do? We're going to subtract 20, and then we're going to divide by 7. And I picked this one because you do not get an integer. You do not get a whole number here. So you get 25 is equal to 7x. Still solving for x, so we would divide both sides by 7. And if 7 will not go into 25 nicely, if 7 will not go into 25 nicely, I have no idea. It's not nice, okay? It's 3.57142857 That's not nice. So if you get something, a decimal that's not nice, you're just going to leave your fraction reduced. Okay, so ask yourself, is 25 over 7 reduced? Anything going to 25 that will also go into 7? No. You can leave it improper. There's nothing wrong with leaving it improper. You can change it to a mixed number if that makes you happier. But most of the time we like improper fractions because there's just two numbers. Mixed numbers and higher level math sometimes become complicated. We really prefer improper fractions. You can give me a mixed number if you want to. All right, questions about number 30? All right. Number 36. Again, solving equations. They're getting a little bit harder. So I asked you this question in the last example. And I'm going to ask again. Are there any excluded values? Yes. In this problem, there's going to be excluded values because I see some x's in my denominator. So you might want to go ahead and make yourself a note somewhere. What can x not be? 0. X cannot be 0. So what that means is, when you solve this equation, if x turns out to be 0, you have to throw it away, and your answer to this equation would be no solution. Okay? So you have to keep that in mind. X can't be 0 here because if you plugged it back in, it wouldn't check because you would get an undefined value. All right, so what are we going to do first? We're going to multiply by the least common denominator, or in other words, something that 2 will divide into, x will divide into, 9 will divide into, 18 will divide into, 3 will divide into, and x will divide into. That's actually called the least common denominator. You may know what that's going to be? 18x. Got to have an x, right? You have to have an x because you have an x in two different denominators. And 18 is something that 2, 9, and 18, and 3 will divide into. Any questions about how I picked the 18x? All right, let's multiply it times the first term. When I multiply times the first term, 2x cancels with 18x and gives me a 9. And so then I have to do 9 times 5. If you can do that part in your head, that's fine. I'm just going to draw this, put the steps down in our notes. When you multiply times the second term, 9 cancels with 18x and leaves you with 2x. And then you have to multiply 2x times 8. Because only the 9 cancels with the 18, and you get a 2, and you still have the x there. Okay? So then you have to do 2x times 8. All right? When you multiply 18x times 1 over 18, what cancels? 18. Just the 18. So then you have an x times 1. When you multiply times the last term, 3x cancels with 18x and gives you 6. And then you have to multiply 6 times 1, and you have to remember to bring down the minus sign. Now to me, this is the hardest step right here. You're canceling kind of in your head, and then you're multiplying. Any questions about where I got the 9, the 2x, the x, and the 6? Be glad to go back and explain that. All right, so go back and explain that. Okay.
So if it's like 2x, and then 18x and 2x cancel out the x, then if it's like 9 and 18x,
9 and 18x, since 9 doesn't have an x, when 9 goes into 18x or cancels with 18x, you just have a 2x left. Does that make sense? All right, anybody else? All right, simplify the left-hand side, and it turns into what? 45 minus 16x. The right-hand side turns into x minus 6. Can you simplify the left-hand side anymore? 45 minus 16x, anything combined over there? No? Can you simplify the right-hand side? No, so now it's time to solve. Do you have x's on both sides? Yes. Which one's the smallest? Negative 16x. So let's move it next. That's going to leave me with 45 is equal to 17x minus 6. And then I finally have 1x. It's over on the right-hand side. 17x minus 6. I'm solving for that x. So my next step would be what? Add the 6. And then you would get 51 is equal to 17x. And then you would divide both sides by 17. So you're going to get 51 is equal to 17x, still solving for x, divide by 17, and x would then be equal to 3. Can x be 3 in this equation? Was it our excluded value? No, x can just not be 0. So that means your solution is 3. If you want to go back and check it, you can. If you want to trust that you solved it correctly, you're good. All right, questions about 36. All right, 42. Do we have any restricted or excluded values? Those mean the same thing. Textbooks call them differently, different things. Excluded or restricted means the same. Anything that x cannot be? 2. Okay? So you might want to write that down. Sometimes the book asks you, it prompts you to think about what x cannot be. Sometimes it doesn't. And you just have to know anytime you have an x in the denominator, there's an excluded value. Okay, I need to clear the fractions. Okay? I need to clear the fractions. The good thing is that both of the denominators are exactly the same. Okay, so that means that we already know what we're going to multiply by. We're going to multiply by x minus 2. If all of the denominators are the same, we don't have to find a common denominator to multiply 3 by. So we're going to multiply everything in this equation by x minus 2. When we multiply times the first term, what cancels? The x minus 2's cancel, and I just get a 2. Equal, multiply times the second term, what cancels? X minus 2's, and I just get an x. When I multiply times the last term, nothing cancels. Okay? Nothing cancels because I don't have an x minus 2 in the denominator. So you've got to bring down minus 2, and then you have to multiply that minus 2 by the x minus 2 because it didn't cancel. The x minus 2 did not cancel when you multiply times the last term. Questions about this step? I think this is the most crucial step. The rest of it just is solving. The left-hand side is simplified, but the right-hand side is not. So we're going to work on the right-hand side by distributing a negative 2. So we're going to get x minus 2x plus 4. And my right-hand side can be simplified because I have 2 like terms. So I'm going to go ahead and combine those together. And I'm going to get 2 is equal to what? Negative x plus 4. Do I have an x on both sides? No. So I'm just looking at the side where the x is. It's on the right-hand side. And the next step to solve would be get the x by itself, so I would do that by subtracting 4. What is 2 minus 4? Negative 2. So negative 2 is going to be equal to negative x. I still have not solved for x because that's a negative 1 times my x. So I'm going to divide both sides by negative 1. And finally, x comes out to be positive 2. But guess what, guys? X can't be 2 because if I plug 2 back in, I would get an undefined value. So that means since 2 is excluded and you got 2 for your x, you have to throw it away. Okay, you have to throw it away, all that work, and you ended up with an excluded value. And so if the only answer you have is excluded, then the answer to this equation is no solution. Okay, if the only answer you have is excluded, and you throw it away, which you're supposed to, then your answer is no solution. There is a symbol for no solution. It also looks like the empty set when we did intersection and union. You can see no solution written out, or you might see the symbol 0 with a line through it. It means no solution when you're solving. All right. Watching my time here. We're going to set number 50 up. We're not going to solve it all the way out just for the sake of time, but I'm going to show you how to set number 50 up. Any questions about 42? All right, let's look at number 50. So probably the most complicated one that we've seen as far as having denominators. I got a bunch of denominators, but I need you to notice, I need there to be a little red flag that goes off. What's the red flag or the yellow flag about x squared plus x minus 6? It's a trinomial. And when we're finding common denominators, what did we do back in section P6 when we were finding common denominators and we had a trinomial in our denominator? We factored it, okay? You're going to want to do the same thing here. Are my signs the same or different? They're different, so I'm going to have an x plus and I'm going to have an x minus. This is an easier trinomial, so I'm looking for two things that multiply to be negative 6 that combine to be positive 1. Negative what? Negative 2 and positive 3. Okay? So before you try to find something to multiply through by to cancel out your fractions, if you have a denominator that's not factored, you have to factor that. Okay? Or the problem just becomes horrible. Alright? So we want to clear the denominators. We want to cancel them all out. So we're going to set this one up. What would we multiply through by if we want to cancel an x plus 3, an x plus 2, an x plus 3, and an x minus 2? Let's make sure I didn't write that one down wrong. Let's see. X minus 2. Oh, this is supposed to be minus 2. This will make your life easier. This second one's supposed to be minus 2. My bad. Alright, so we're going to multiply by what? An x plus 3, and we're going to multiply by an x minus 2. Okay? So if you have a bunch of binomials, if your binomials are what's in your denominator, then you just need one of every binomial, and that'll cancel everything out. Alright, we're going to do the next step, and then we're not going to solve it all the way out. This is just the step I'm most concerned about. So when you multiply times the first term, what cancels? X plus 3's, and then you're going to be left with 6 times parentheses x minus 2. When you multiply times the second term, what cancels? X minus 2's, and you bring down minus 5, and then you'll have to multiply the minus 5 times x plus 3, and when you multiply times the last term, all of the binomials cancel. The x plus 3's cancel, the x minus 2's cancel, and you just get negative 20. Okay? So factoring, finding what to multiply by that will cancel all your fractions out, and then actually multiplying by that, to me, that's the hardest part. Okay, could you go from this step on to the end?
Yes.
Okay, so we're not going to take our time in our notes, but we would go ahead and solve. Just put a little squiggly line. On this one, we're actually going to get 7. Is 7 an excluded value? No, we actually forgot to do that. What are the two excluded values? -3 and +2. So is it okay for x to be +7? Yes, it is. Okay, and if we plug that back into the original equation, it would solve. All right. In the next set of homework problems, they're going to say, find all the values that satisfy the given condition. Find all the values that satisfy the given condition. And they're going to give you some stuff that looks like calculus to begin with, but I'm going to show you that it's not. They're going to say y sub 1, something like this. Y sub 1 is equal to x plus 1 over 4. And they're going to tell you that y sub 2 is equal to x minus 2 over 3. Alright, that looks kind of horrible at first. And then it's going to give you some more information. And then it's going to say, and y sub 1 minus y sub 2 is equal to -4. So that would all be in your directions. Alright, those would be your directions. So if you saw these directions, y sub 1 is equal to this, y sub 2 is equal to this, and y sub 1 minus y sub 2 is equal to -4. So what they're doing is they're giving you information to write an equation. This is your little equation right here. You just got to plug in. So what's y sub 1? X plus 1 over 4 minus y sub 2, which is x minus 2 over 3. And according to your directions, that's going to be equal to -4. And then you would just solve it from there. Okay? How would you, what would you multiply by to get rid of your 4 and your 3? 12. Okay, we're not going to solve this out. We've practiced solving. We would go through all this stuff. And I'll just tell you that the answer for this one is, which one is this, 54? The answer for this one is 59. I just want to show you how to set these up. We've already shown some examples as far as how to solve. Okay? Questions about 54? Alright, I do want you to write these 3 words down. I want you to write identity. I want you to write conditional. And I want you to write inconsistent. And when we're talking about equations, okay, when we're talking about equations, equations can be put into these 3 categories. They can either be an identity equation, they can be a conditional equation, or they can be an inconsistent equation. The most common is the conditional. So I'm going to start with the conditional. The conditional equation would look like x equals -5. Okay? An example of a conditional equation means that this equation is always true, okay? Or it's true only when x is equal to -5 or +5 or 2 or -10, okay? So when you solve out and you get x equals a number, that's considered a conditional equation because that equation is only true when x is that certain value. If an equation is inconsistent, okay, if it's inconsistent, then your solution would be no solution. It's inconsistent. There's no way the left-hand side of that equation is ever going to equal the right-hand side of the equation. So that's when you actually get no solution. Okay? Identity means the left-hand side is always going to equal the right-hand side. The left-hand side is always going to equal the right-hand side. When that happens, your solutions are all real numbers. Now, you've seen an example of everything in our notes today except all real numbers. So I want to show you an example of all real numbers. So when they asked you what kind of equation you have, what type of equation you have, these are the types of equations. Your equation will be one of those 3. It'll be an identity equation, a conditional equation, or an inconsistent equation. It depends on what type of solution you have. If they're asking you for the solution of the equation, it's going to fall under, it's either all real numbers is your solution, x equals some real number, or no solution. All right, real quickly, let me show you one thing. Let me show you how to get identity. Anybody still copying that? All right, so last example. What number am I on? I'm not doing numbers, I'm doing problems. This is just an example of identity. And you've seen this. When I show it to you, I think you'll remember it from Algebra 1. So let's say you had a real difficult problem. You multiplied through by the least common denominator. You simplified the left-hand side and you simplified the right-hand side, and you had x's on both sides. What would you do next? You would subtract 5x from both sides, and something crazy happens here. That hasn't happened in anything that we solved today. What happens? Okay, both sides cancel, and you're left with two things that are not, you're left with two things that are equal. So if your variables go away and you're left with two numbers that are equal, that means it doesn't matter what x is. X can be all real numbers because those 5x's are always going to cancel, and the left-hand side is going to always equal the right-hand side. So this is when we say our solutions are all real numbers, or we use this darkened R, that means all real numbers. If your variables cancel, then you were left with something that was not true. Okay? So if you were left with positive 5 equals negative 2, that's not true. And therefore that would be no solution if your variables canceled out. All right, your homework assignment, let me verify this or make sure that you understand. I've not given a homework assignment like this before. Your homework is page 112.